Okay, once then, today I'm going to talk about some of the basics of just the basic physical properties of masonry, just some general things to know. So dimensions, as this has been mentioned several times, but you can think about the blocks in terms of their nominal dimensions, and then their actual dimensions have 3/8 inches less for the mortar joints, not the grout. And then you can get different sizes. It kind of depends on the manufacturer, the exact size you get, but a lot of the options vary upon their width. So the distance from like the inside of the wall and outward. And then that determines your wall size and that sort of thing. And this is something I think Jeremy mentioned some, but courses and planning grids are two ways to help lay out your facade. So courses are a way of sort of grouping lots of individual bricks together in layers depending on their module. Usually courses are 8 inches, sometimes 16 inches, several runs of bricks in a row. And then 24 inch by 24 inch planning grids are usually used to lay out the facade as a whole. There's a lot of different ways, as I mentioned. It really depends a lot on the manufacturer and how you're using the brick, how you want to define this dimension. One thing that's very important is the net area, which a lot of bricks and other masonry is used for walls. So you mostly need to know its axial area horizontally because that's holding down the compression. So usually the net area is considered the amount of area horizontal that will take force in a wall, that sort of thing. And then a lot of brick, if they're trying to make them a little bit lighter and still as strong, they have like cores or cells or what they're known as. And I think Jeremy mentioned some of this already, but units are usually rated solid if more than 75% of their volume is solid, so they can have small cores. And then if they have less solidity than that, they're called hollow units to be lighter. Clay masonry, there's a lot of different options. These are just some common ones. The most common is the modular size. You can see its dimensions there, and this I wrote below its nominal dimensions plus the 3/8 of an inch. But then there's a lot of other sizes depending on the thickness of the wall you want and the other architectural reason for choosing those. The Masonry Design Guide, Chapter 3, has a lot of dimensions, and that's where I pulled most of these sizes from. So if you're looking for more info, that would be where I would check. CMU, typically they vary just by 2-inch increments of their width. So the most common, I believe, is 8-inch width, but then they can go up all the way to 16-inch width. And then CMU are a lot more hollow than bricks, obviously, and their webs are usually at least 3/4 of an inch thick to about 1 1/4, but you can see some variance beyond that of less or more. These are just the most common sizes. And then glass block masonry, once again, they can vary a lot, but the most common are squares that are 6 inches by 6 inches, some 8 by 8 and 12 by 12. But there's a lot of options I saw online, so like for certain corner glazing or rectangular pieces, and then you can vary those along the facade, so different sizes working in conjunction, as you can see on that picture. One other thing that's really interesting that I didn't know about glass blocks is some of them are hollow. They'll take 2 sheets of glass and just leave a vacuum in the middle, whereas some of them are solid. And you get a little more strength out of the solid ones, but they're obviously a lot heavier, so depending on how you use them. And then the last is stone. Stone has the most variance because obviously you can order whatever size you want. And then you can either buy them in just full blocks and use them more for structure, or you get sort of sheets of them and use them as a facade covering. And those sizes usually are 2, 3, 4 inches thick is what I saw, and then that you would just hang on to some other structure. Next I'm going to talk a little bit about strength. Well, once again, you're going to see a lot of variances in strength. Something that is important is how they test for the strength. I didn't realize this, but depending on the procedure, you can get a different strength value for the same masonry. One of the reasons is for Poisson's ratio, something we're learning about in strengths. When you load the masonry, it's actually going to expand out to the sides, and if its horizontal area is larger, it'll hold itself more compact, and that friction actually gives you a little more strength. So as you can see in this top right image, as that block gets compressed, it's stretching out, and if it has more horizontal area, that actually pulls it tighter together. So you get a little more strength if you do it that way, versus taking a small core sample, you'll get a little bit of a lower value. So one thing to note when you're looking at the strength of a brick is how you're going to use it versus how that value is found in a lab. So that can be important at times. And then the ideal test would be using the most net area horizontally and getting a fully uniform loading onto it. ASTM has a guide about the best way to test masonry units, and the best way is to get a thicker sheet of steel and put that at the top of the bottom so you get full uniform load across the masonry. This image kind of gives you a general idea about what that would look like. Even though we consider masonry to be a brittle material, it does have some bit of a stress-strain elastic relationship, and it really depends a lot on how it's made and the mix. But for a lot of these, they actually can be given a modulus of elasticity, and there's some information in the textbook on how that's calculated. I know one thing that's common is you take a 33% of the total strength, and then you just draw a linear relationship, and you use that for your modulus, and that can be a decent way of evaluating the stress-strain properties, but that can vary as well. And then tensile strength, we don't really think of masonry as having tensile strength, but there are several ways to test for it and to get a value if you need it. One way that I found that was really interesting, and one of the most common ways, is called the splitting tension test. And basically, this funny little image here, you actually apply a linear load to the top and bottom, and it almost shears in a way, but you can use the cracked cross-section that you see there and calculate a tensile strength value from that. And that can be used in design in certain situations. There are some other ways to test for tensile strength, but they're usually harder to do and a little less accurate. So if you're trying to find the tensile strength, this is the best test for it. This was a really interesting table that I found in the book, and once again it shows kind of the relation of the tensile strength to other properties, and I think this may be something we'll discuss later, but chapter 4 in the book has a lot of information on these sort of just basic physical properties. So if you're looking more on that, you can find some stuff there. So the masonry itself, masonry by itself is not allowed, really not allowed in the code to have a pure tensile strength, so one block by itself you're not really supposed to use for tensile purposes, but if you have several with mortar in between them, you can sometimes use a little bit of strength, as we talked about before, the modulus of rupture. I think we mentioned this before in class, but table 9.1.9.2 has some values that you can use, but I don't think that's commonly used in design, but you do have some options depending on how you're using it, and this is that table. So it really depends a lot on the type of mortar and like how it's put together, and we may get more into that later, but I don't think we don't typically design with the modulus of rupture, so that shouldn't be too important. The shear modulus, something we haven't talked about yet much, is the shear strength of the masonry, and one important property is the shear modulus, and you can actually calculate that similar to the regular modulus. You take the strength of the masonry, and then you can calculate the shear modulus, and as I mentioned, the design guide in chapter 3 has some more information on that. I think I included that table in this. Yeah, so here's some modulus of the elasticity and the rigidity modulus for clay masonry, and there's also one for CMU masonry. And both these properties just vary on the strength. So when you're talking to the manufacturer about what you're going to use, you'll find out all this information and can calculate that. The last thing I'm going to talk about is a little bit about the density of the blocks. The most important reason we need this property is just calculating self-weight. So clay masonry is typically about 120 PCF, and some of the lighter masonry that we use, that and CMU, are a little lighter. But it really depends on how it's made. So, and sometimes some of the heavier masonry is heavier bricks can start heading more towards concrete weights, and then stone usually weighs about 150 PCF, but that can vary a lot. And then CMU, I was expecting it to have weights of about 150 PCF because that's what we use in our concrete class, but for masonry, it's typically a lot lower. There's 3 classes, the lightest being less than 105, so it's actually lighter than I was expecting. And with a lot of the cores in CMU blocks, they're really not nearly as heavy as you would think. And once again, this table, I think, came out of our textbook in chapter 4. This talks a little bit about stone density and its strength and how that varies for different types of stone. So that's something that, depending, not only are you going to use stone, but what type of stone is going to have variance for all of those. Okay, and then before I finish, if you're looking for more into just general tables on a lot of properties about dimensions and weights of certain blocks, there's a lot of information in the design guide appendix A. So whenever you're needing to use masonry, and you need to know dimensions and that sort of thing, that's a good place to check. So, any questions? Yes?
Are the CMUs kind of the center block looking block that we would see on a lot of commercial buildings like Walmarts and whatever? Okay.
And those, as I mentioned, those are actually going to be lighter than normal concrete values, which I was expecting them to be about 150, but typically it's a lot less.
Because the voids.
Yeah, the voids and just the density of the material is less. So they're large blocks, but they actually don't weigh as much as you would expect.
There's a table, and I don't know if it's in that textbook, but there's a table that tells you how much a wall would weigh
per how many
what
CMUs.
What type of grout you're using. If
Oh.
it's fully grouted, so then you can kind of see the difference in what it weighs with without grout.
Okay, very nice.
So then you don't have to add it all up and weigh,
Wait.
the whole wall. It just gives you.
Sorry, I'm thinking out loud. You talk.
Any other questions? Okay.
I do have one comment. Not necessarily in regards to yours, but you did not show us the two tables that I was looking for.
Is this?
No, that's okay. That's okay. So we're going to leave it up to.
Okay.
Amanda.
We're going to leave it up
I'm
to
just kidding.
Jeremy and Hope